Yes, we can slowly start as the rain is heavy outside and probably people are arriving late a little bit due to the weather. I think it's good to review what we have been doing. I think this is my last lecture. I mean, the next Monday will be the review section for the past paper. So this is the last class, So make sure that you ask the question. If not, then will be the next one. So happy that we are almost done. So but although it's almost the last class, but we hope that you still pay attention because there's very important topic. As I said, I mean, you learn this more when you go to the further levels, but it'd be great if you recall what we are doing, right? So simply put, the regression is trying to study how two variables related, right? And the data you have is for each individual, you have two measurements, right? In ANOVA, you have observation and groupings. But now we are looking at the variable x and y, right? And do note that we actually don't restrict x to be any kind of value, right? So x actually can be 0 or 1. Then you allow categorical, in that sense, right? So you can actually do, it will turn out to be later you will see, if you learn further, actually you can concept B is 0, 1, then it become a t-test. Okay, but the interpretation you will learn and if you learn in advanced second class of the statistics. But the main idea is to try to have a line that represent the data, right? Basically, the idea simply means you are, as we do data analysis, right? So the most useful one is data by itself, right? So what you're doing, the line is simply that I simply reduce the dimension of data to 2 numbers, right? Which is slope intercept. And in that case, basically you describe how x and y related, right? Because the data only gives you 5 number of points. And by drawing a straight line, actually you are saying that every possible x is related to every possible y in particular way, right? So it is a very general idea, right? Just you simplify the data to 2 numbers, but this extend to every number possible, right? So basically, it's just like the modeling, right? Basically, just like you have a data that captures some part of the world, right? And then through the modeling, you simplify to a very simple model, and that apply to everything in the population. So that is very important, right? Because A and B or will be the things that we estimate, right? It's the vertical distance, and this vertical distance, a formula here, right? And turn out these are unbiased estimate, right? Of if we think that the underlying the world is related to alpha and beta. If you want to talk, you keep the voice down a little bit. Yeah, yeah. So it's related to alpha and beta. Yeah, if you want to talk, either keep the voice down or you can sit closer. Yeah, it's okay, but it affects others, right? So so we have 4 different kind of assumptions that would make our regression model work, because why minimize vertical distance makes sense, okay? And these are the 4 assumptions that we're to make. And if you learn in the future, always you would have to make some assumption for behind your model, okay? And these 4 model, I guess, these 4 assumptions would be, of course, you will say they're restrictive, but you will learn, if a second class, you will learn how to relax them one by one, right? So suppose you think it's nonlinear, then you just put nonlinear term in a multiple regression, right? If you think that these are not correct, then you could just modify the assumption, right? Say suppose you think that they are related, then you won't learn time series model. Okay. And then if you have this one is easy to do. If you think this is not correct, then you can just simply have a better structure of the random term. Okay, so that they can be easily done. And this one, there are other techniques to handle this problem. So you would build a much more complicated system, okay, to explain how the x arise, and then you have a multiple equations. So these are all very restrictive, but that's how you start, right? Okay, just like the Newton law of motion, right? You start from something, then you build the rocket or the sky, right? Because based on these basic principles, right? And we learned that the A and B are unbiased estimator, right? So, and also they're efficient. And we learned the interpretation of A and B, right? So the next thing we cover that in the last class is once A and B, then what next, right? Once of the model, right? So we say it's good, but we really want, we learned from the previous chapter is we not only just want to know the point estimate, right? We know it's good point estimate A and B, but we want to know two things. What is the confidence interval estimate, right? So we A and B give you the best, but what about the best case scenario, the worst case scenario, right? That is what we say confidence interval, right? And also we want to know how good is the regression, how fit it is. Later you see the R square. Today we'll cover. And we also want to do hypothesis testing on the alpha and beta, right? Because we want to see whether alpha is actually 0 or beta is 0, right? The data will tell us whether actually A and B, sorry, alpha and beta is 0 correspond to whether the underlying, say, the data has x and, say, beta equals 0 is asking whether x and y related, right? Beta is 0, then they're not linear related. Okay. So I think we have been here. Okay. So we pretty much stop it here. Okay. And we talk about hypothesis testing. We'll go again. So if you don't like the math, that this is the formula we give you. Okay. So you can take it, and then the declaration is already in the slide. So if you want, you can go check how to prove them. It's not super complicated. I mean, anyone with high school math can take some time and understand what's going on there. It's not something terribly complicated, but I don't want to spend time on that. But at least if you assume the error are normal, the A's are normal, right? That is the idea of the thing, because alpha and beta are non-random, X are non-random. So the only random part comes from is the epsilon I, right? So then our first thing, right, to emphasize is why you want to test that, right? You want to do a t-test, right? You want to say what is alpha? Alpha is the value of y on average. What would be when x is 0, right? And you want to see whether there's a 0 or not, right? So sometimes it makes sense, sometimes doesn't, but to do it is rather easy, right? Because that's the same as the usual t-test, right? The usual t-test is because this is normal, right? Because we know alpha actually is a normal, right? If epsilon is normal 0 sigma square, right? We know that this will be, sorry, alpha A, right? A is a random variable, alpha is not, right? A have mean alpha, right? Sigma square over root n, right? And sum of xi square, right? And sum of xi minus x bar square, right? So that is the thing. It's normal, right? When we told we're normal, if we give a sigma, then you can do a z-test, right? You learned that, right, a few 2 topics ago, right? And then if you don't know sigma replaced by s, then you do a t-test, right? The same idea there, but we don't want to prove that part, but just do a t-test, right? You want to see how the t-test, right? Because the main idea is like this, right? Just to go back in case you are not aware, A is a random variable, right? Alpha is there, right? If this is true, right? If you say this is 0, this is 0 here, right? The idea is like A should be around this, and we claim this is 0, and that means that if this is we're close to 0, then we say our data is actually support this guy, right? If our data is far away from that, then our data support this guy, right? Then usually we put this 2.5%, right? Or we say 0.025, right? Because the inside 95, right? We allow some error because even this is true, right? So you have some chance to go to two-way, but we have said that, okay, what is the thing that we think is too far, right? In terms of probability, we say that is 5%, right? Add together on both sides will be our way, right? These two tail tests, right? Of course, you can do one tail, but the same idea, right? You do one tail, then you put 5% on one side. But since we don't know sigma, that means that we have to use that t-test, okay? And this t n minus 2 here, okay? And there's some reason why n minus 2, and I explained already because you have x bar and y bar being estimate instead of n minus 1. And later you will actually see when you learn second class, if you have more regressor, there will be n minus k minus 1. So the more you have, the this one will be much more fat tail, okay? So let's see here, right? It's also, the first thing is Hubbard testing. The second thing is common interval, right? So A, as we said, is already the unbiased, efficient blue, right? Less linear unbiased. So A is already good. So then you want to say, well, okay, I have A, but what about 95 or 90% confidence, right? So the same idea there, right? Just you recall, right? If a two-tail test, right? You just multiply the critical value by the denominator, right? And plus minus will give you the that will give you the margin error. That's why plus minus, right? So that is the standard thing we have know already, right? So here comes we covered last time, right? How you test that, right? That is just copy the formula and put numbers in, and that's what you get, right? Why I do that? Because this is the outcome Excel gave you, right? So you have to know how you arrive, how Excel outcome comes about, right? Not necessarily you do it by yourself. I think I asked you to do it for your assignment for once, but for the rest of your life, I mean, pretty clear, you just rely on the Excel output, right? Or any Python output. But these are the math behind it. So I want to let you know why you know this right? Because you don't blindly trust the outcome, right? You know what's going on. You don't have to know every single step, but you know where it comes about, right? So hopefully that is clear what it is, but you can easily see that it includes 0, right? So you can't reject it now, right? Because 0 is there. So actually we'll do the same for the slope, right? The slope is turned out to be, actually the formula is much more easier. I don't want to do the proof, but the same idea goes on. You want to remember the slope, right? Your data is very concentrated, right? The slope will be very volatile, right? Because if the data is all around X bar, then the slope can be anything easily, okay? So, and also you have more variation, the variance of B will be larger, right? And that's why you give you, if you assume the error terms, the random terms are normal, then the slope is also following normal, okay? And that gives us a standard error, okay, SB. And the proof is behind here, but I don't see you want me to go for the proof, because this simple case, if you learn the second class, you will know that you will not use this formula. This is very classical, because the reason why I don't want to talk too much about this proof is because this is a very classical thing. And when you go to second class, you will immediately drop this assumption. Once you drop, all the formula will become much more complicated. So that's why, I mean, if you learn it, you become obsolete very soon. So why bother? But if you want to know the proof, it's there, right? If you want a more complicated assumption, it will be a more complicated proof. So I don't want to bother you with the math since many of you are not, this is the last class for statistics. So I just want to know what is the taste of doing statistics and what you may see in the future, because if you, after 5 years or 10 years down the road in the business world, you may come back for master program in some other school or our school, right? Do the M.B.A. or EMBA, then you do statistics, right? And these days, right, it's hard to imagine that you think about a business decision without using data, right? The time that a very smart person looking at what's going on and don't look at data to make decision will be something past, right? Everything will rely on data and measurement, because before we have someone for business sense, they understand without looking at data, but now everything is measured, right? You can data, right? If you cannot justify by data, then probably it's a problem, right? It's not saying data decide everything, but if your thinking is not supported by data, then it's very dangerous. Okay, and then very often, right, data cannot tell you everything, right? But if data reject what you think, that is a problem, right? So we have the other formula here, the same, right? The B over SB is n minus 2. You will see this thing there, right? This is the best point estimate, right? You multiply by the denominator by the critical values, so it will give you the marginal error, and that give you the cumulative, right? This is the same, right? There's no different from one-tailed test, right? Same as t-test, one-tailed, the same thing. Okay, the only thing is n minus 2 here. Okay? So here is the some boring math. I can go through this one with you because I didn't go through this one. So the math is very simple. Just as we have calculated, right? And you have the data as x is this guy, right? Take every data minus the mean and square is 10. Okay. And SB is just this S over 10, right? This over this guy. Give you this number, right? And remember the slope you calculate, which is B. B is 0.7, right? So this number over this guy, right? Give you 1 point something, and then actually even without calculation, you know, you can't reject it, right? Because at least it's more than 2, right? So then you can't reject, but of course, because of the data is very limited, so that's why like this. Usually when the data has like 100 or thousands row, then usually be because the p-value likely to have something more reasonable. Okay. And you can figure this out, but in case you don't know the Excel, I just put it down there. What is this number? This is a critical value, right? So just to recall, this is Tn minus 2. T is 5 here, so it's T3, right? And the critical value, right? Just in case with the color, right? You put, it's two-tailed test, so 95% is here, 0.95, right? So the other two side is 0.025, right? 0.025. This is 0.025. So if I want to find this critical value, it's 97.25. So it would be T, because I want the probability go back to here. So T dot inward, right? 0.975, 3. And this will give you this number. If you do the 0.025, which is the left-hand side, will give you negative 3.5, same thing. Okay, because symmetry, right? Regardless, you use 0.975 or 0.025, give you the answer, one negative, one positive. Okay. And that gives you this guy, right? Then we're done, right? Or if you want to do the p-value, which will then do it here, right? You can also do the p-value thing, right? What is the p-value of this guy, right? Just draw again, right? T3 here, right? It's 0. This is 1.005, right? The p-value will be this area times 2, right? Because it's two-tailed test, right? And this value you can calculate by T this, right? and 1.0593 true. Do remember that this gives you only the left-hand side. So we take 1 minus, right? And you times 2 will give you the p-value. Okay? Is that clear? So that is what it is, right? But these are all the number you will see in Excel output, which we'll talk about at the end of today, right? So you understand how this number can find there. That's important, right? As I told you, right? The most important thing for the exam will be the very last slide, which show you the Excel output. You know how this number get, where they come from, then you're done, right? That is the main goal of this. Just to, is that okay? Just to remind you that everything we do, right, is actually want to go to the very last slide, right? This one. Everything will be explained, right? You can find all the number here, right? All the number is being shown here, right? The 0.7, t-stat, right? P-value, everything, 95. They are this is redundant, the same thing, okay? But that is how every number will explain, okay, from here. So standard error is the S, right? Where to calculate, right? We'll talk about all this, the rest later. Where is it? Okay, is that okay? So we do this and this slope already done. Okay, this is already done. And then now, I think this is a good question. Last time we asked, is there any relation between ANOVA and regression? Okay, the two. First, if you learn not this class, then later, the other class, actually ANOVA and regression is very similar because you allow multiple group, every variable is 0 or 1, then the grouping can be done, okay? And that you will learn later, so just forget about this link. The second link will be, you can use ANOVA, okay, to test, to do one thing, okay? And there are two things that actually ANOVA can give you. First is ANOVA will give you the two things. First is what we call R square. R square is, later you will see, is how good is the regression. That's why they call the goodness of the fit. Okay, if you look at the textbook or many, goodness of fit. You will see the next X9 anyway. Goodness of the fit. So it means how good is the line fitting the data. Okay, this is the first thing. And second is this ANOVA will allow us to do F test. And this F test is testing what? This alpha equals 0 and beta equals 0. Okay. So it's testing jointly whether the model is completely empty. So, but anyway, that will be something that we're doing. Is it the case? Let me see. Do we take F test? Oh no, just test the beta. Sorry, just test the beta is 0 now. Sorry, just the same as t test. Okay, sorry. So basically the is checking two things. One is goodness of fit. The other is taking beta equals 0. Okay, but of course the F test would not be meaningful in this context because simple linear regression only have one beta. If you have more than one dimension, x1, x2, x3, x4, x5, then you want to test simultaneously all the beta 0, then you will need the F test instead of T. But okay, but the main thing is to do the goodness of fit, the R square. So let us look at this. Actually, again, you have a decomposition. So look at this guy. This guy is what? This guy SST. SST is what? Your data here, X and Y, right? What is SST? Is you suppose the data like this, okay? Then what it means is it's just simply the if you calculate variance, you meet the numerator of the variance of y, right? So basically just, if this is the y bar, right, FHY, right, SST is this guy. That's called sum of square total. Why? Why this? This is actually the thing that we want X to help us to explain, right? The reason is, if I want to know Y, the best model without anything is just Y bar, right? For example, ask me, what is you want to guess someone's salary. What's the best guess? Average in the population, right? The sample mean is the best guess already. So if we want to get X to help us, it better help us to explain that is not explained by Y bar, right? So that part is the sum of square total, right? It's called SST. It's the thing that we want to explain through our model with X. Okay. And the next part is SSR. Is later you will see, actually I draw it, will be the part that explained by regression. Okay. Y hat is the line, right? Maybe I use green color, right? So your regression line, suppose this is the regression line, right? So SST will simply that how, say, this is SST, right? How your data this point compared to the mean, okay? And this is the part that you propose to explain. Okay? Is that clear? So how your regression line compared to the mean is the part that you propose to explain. Okay? And I draw this SST wrongly. It should be this guy, sorry. It should be this one. It should be SST. Okay. Sorry. It should be SSR. And suppose this is the data point. Let me erase this, make it clear. Okay. And this part is SST. Okay. And then you look at the difference between these two. It's called SSE. Okay. And similarly, if you have another point here, let's draw another point here. Suppose the red is here, okay? And this part is SST, right? And this part is SSR, okay? And this part is SSE, right? So, and of course they're square. So it can be proven that actually the SSE is what? SSE, I mean, before I prove, SSE is a part that unexplained by the model, okay? That is called sum of square residual, okay? If you are aware what SSE is the thing that is our objective of the regression. We are minimizing the vertical distance, sum of square. SSE is the thing that we minimize, right? We try to find a line that minimizes SSE, okay? And therefore, we define R square, as we said, the goodness of the fit of the regression is SST, things we want to explain, and things we have explained. Okay? Or if you like, that is better writing, to be SSE over SST. Why? SSE is the part unexplained, right? Over what you want to explain. Okay, though that is the part unexplained, 1 minus. And turn out in the regression, that will be, they relate in this way. Okay, so R square, because of the formula, Why it's good? It is because it is always belong to 0 and 1. And in the 0, the fit is most awful. 1 is on a straight line. Okay, so that is what I say. But you see the slide later. Don't worry. Everything is drawn here. Is already in the is here. So this is the SST. The whole thing I'm going to explain. SSE is the part that is not explained by the model, and SSR is the thing explained by the model. Do note that our goal in this regression is to minimize SSE by choosing different slope intercept. Okay, so that's why SSE over SST is how much we fail, right? So that's why 1 minus that will be how successful we are, right? Because SST is the target we want to explain, right? If SSE is 0, then we are good, right? So SSE over SST is how much we fail ourselves, right? Because if SSE is 0, everything is nice, perfectly there, right? So that's why how good our fit is 1 minus, right? That's called the R squared. And later, if you learn any machine learning classes, R squared is the way that you try to compare different type of regression. Okay, but that is slightly beyond what we are doing. But you can see R squared is very useful. Cat lead, and then okay, just to remind you, SSE is the thing that we are minimizing our regression, and SST is our goal, right? Because if everything falls nicely, SSE will be 0. Because SSE 0 means everything is on the line, right? So that is called the coefficient of determination. How much is being determined, right? Yes, that's R by SST, right? But sometimes I prefer the 1 minus version, I think, which is easier. And you will see this is a big R square, okay? And then you may wonder how it related to our small r square in chapter 1. Turn out to be in this framework, you have 1y, 1x, same. Small r square is indeed the big R square. Surprisingly, right? Probably not, but if you are interested, this R square is exactly the same as the correlation coefficient, right? So if you calculate, it will be covariance xy, right? The square root variance of x, variance of y, right? The same thing. Okay. Now, this is R square. Later you will see is in our model, right? And already explained already. Okay. So how do you calculate that, right? So just show you this one again because I want you to know what's going on, right? So how you do that? So you have the data like this, right? Calculate the mean. This is 10, right? And this is 11, and this is 20, and that means 30. 30 divided by 5, which is 6, right? So that's why 4 minus 6 square, which is 2 square. 7 minus 6 square, 1 square. 6 minus 6 square, 0 square, right? Actually, I should write square, but anyway, you know it. 4 minus 6 square, right? 3 minus 6, 18. Okay. This is things that want to explain sum of square total. And what we actually sum of square regression is, remember, we have A and B. I mean, B, I think 0.7, right? A is what? A is, what's A there? I forget. A is 3.9. So we run the regression, that is 3.9 there. Okay. 3.9. Okay. So how you get this number there, right? This is our regression line, right? Simply 3.9. This item is 3.9 plus 0.7 times 1, right? That's a formula, right? It's A plus B x is y hat, right? That's a line, right? We have the slope B and intercept A, right? So it's 4.6. You can do the same for the rest, right? And what you're going to do with SSR, right? The formula, remember, is head minus bar, right? So each number minus 6 square, okay? Minus 6 square, minus 6 square, minus 6 square, 4.9. Okay. Actually, it's here, right? We minus that. And SSC is what? SSC is looking at how the head and how the y are different, right? So this minus this, this guy, right? This minus this guy, right? And you square each one. Also, not the head. Is this one, right? They give you this guy, right? Because SSC is the formula is y head minus y, right? Is how your prediction different from the actual data, right? And you take the ratio of SSR of SST, right? That is 4.9, okay? It's 2 squared, right? The correlation coefficient is R. Give you the same result. So you can calculate the correlation coefficient with a small r and square that, give you big R square, okay? And of course, when you have more than one regressor, which we'll learn in the next class, next course, then this big R square and small R square will be have other relationship, but that will be not that's why you have another term there. Okay? But in simple linear world, this correlation coefficient, take square will give you this. Okay. And okay. So just to quickly show you, R square can actually done in Excel fairly quickly because we have a R square function. Okay. So before the break, I think it's good to show you two Excel functions. Let me copy the data first. Y and X 7, 6, 7, 6, 4, 9. 4, 1, 2, 3, 4, 5. Okay. Just to remind you, we have, let me clean out the thing, right? So this is the data we have, right? And we learn several things here. First is how to find the intercept and slope, right? Last class we did that, right? Which is coming from the intercept of y and x here, right? So this gives us the A, right? This is the thing, right? And you also do the slope as well. Okay. And now I want to say S, which is the standard error estimate, right? We did that as well, which is S is this guy. We've been doing that all the time in our this S, right? Which is the this guy. Okay. Can actually come from the, we call STD STEXY, standard error of YX. Okay. You put this and that, we do S square, which is the same number that we got from the data. Okay. And now we want to show you the R square. It's actually there. It's called R SQ, R square, SQ square. It's just Y and X. Okay. So actually Excel is convenient, give us all the information we want, right? And also, if you are wondering, right, coefficient R, right, which is CORR, right? If you recall, this is what we learned in chapter 2, right? And we have R square, small r square. If you take square, this guy raised to the second, same as we see, right? So we just kind of prove they're the same. Okay? Of course, you have to do the math, right? But this in the slide, but that is the main idea. You can see in Excel quickly, you can do regression without easy. The point estimate are easy, right? Of course, if you want to do hypothesis testing, that will be a little more complicated. Okay? But that would be the main idea there. Okay. So one last thing I want to do with before the break, which I will talk about again, is to mention the thing that I talk about at the very last is we want to do a analyze ANOVA. We would have an F test. Okay, an F test is looking at MSR and MSE. MSR because this is only one group plane. So basically, you can consider ANOVA with one group, two group, right? Right. Actually, it's a t-test, right? It's two group t-tests. Okay. When one group, you have C minus 1, right? So grouping is 2 minus 1, so that's why it's 1 there. Actually, it's 2 minus. Actually, this one is actually, if you remember ANOVA, the grouping here is actually C minus 1, but C is 2, only 2 groups, 2 columns. Okay. And the MSE is the same as before, right? M minus C, right? If you remember, it's M minus C there. Okay. And that means that this is the same as the standard ANOVA, right? ANOVA would do the one group, sorry, 2 group, right? And that's why you can, the same as ANOVA, right? Because you're comparing the case where you have beta, don't have beta. And turn out this is just a standard ANOVA way is the right tail test. Okay. And you can, and turn out if you do the math, this is exactly the same as a t-test. Okay. I don't want to do the proof, but you can check the slide over there. It can tell you that you can do the calculation, which I will go over that in more detail at the break. Is you can do the same F test and turn out this T, well, interestingly, T squared is F. Okay, so everything you square that from F. Okay, and that actually same as the what we have when the F is 1 something, that is same as the T. Okay, but we'll talk about that after the break. And after that, we only left with one final thing of the break after the F test. The one final thing we'll cover is the final important thing is how to use the model, right? Once you establish the alpha and beta are not 0, express beta are not 0, we use the model, right? The model is a line we establish is useful, but the line is useful as a point estimate, right? We want interval estimate. That's what I said all the time is the Python satellite image, right? With the line there with prediction, very nice. We want the range as well. So that marks the end of our course and our class. Okay, but before that, the break, I'm sure that you have a lot of questions. So please feel free to put a real reply here because this is the last time we use this beautiful room. After that, we go to the other room in the central campus. So enjoy. I mean, I'll see you in 15 minutes time. Oh, yeah. It's very fun. It's very cool. It's very cool. You can capture the so
that rotating, that gyro thing.
You see?
Yeah, keep moving with me. Do you like a thing on your? No, nothing. You just know? No need to do anything. Because they will focus on, they will sense who is in the lecture room. You can try yourself. You go there to attract you. See? So this is very the fancy, the most fancy room. It's just another. Because we have one at school, but like you know that like box you're wearing. Yeah. There's like an archive. No. Just look at who is there. Right. So you don't want to be watched that as well. I disappear. Yeah. It's you the recording goes why don't just estimate the camera power. The power. We have the best in the world. I am thoroughly impressed. Yes, that's the best in the world. Camera. Although the camera is the best in the world. We have to do them with it. The best camera face recognition. Found it. Really? Concept. Yeah. Sound. Both the way it is. And they work on. Yeah, they look at it as something like 100 pages. I don't we have a class. I actually have another class here called this is in this exact room, and we actually talked about like facial recognition sounds really like Python do it in just like not a regression, but like it looks like it just looks like yeah, that would be easy. That happened. He was ready. Right off. Okay, this guy, I'm waiting for people out in the camera. This guy is looking at his phone, not working. All that in the office? In the office. Like in the actual office. Actual office. Okay, this guy looking at McDonald's, okay, he's not buying a car. I don't know. That might feel a little, I don't know. I mean, I'm not going to do it. What technically they're doing. I have no normative judgment. There's only positive association. I'm not saying there's a no moral or this one is capable. This striking one. That is you make all that. Just tell me what teacher do it. Just tell me what is capable and not. That is very remarkable. Yeah, it's very good technology. You don't need to keep track of it. Just move around it. Oh, no.
I think this should be use this one. Yeah. Should four. Yeah, should be correct. Use the formula in the slides, correct? Because I check. That's how they define. This is how they define. Just a very quick announcement. A little bit is there's someone discover a mistake in my screens aside box. I think I also received that is this it should be the not 408 but instead it should be using 444 here because that is you replace everything by the x11, right? Replace it by 4 here, and subtract is vertical mean and horizontal mean, and add back the total sum. So this would be instead of 3, right? It should replace by x12 with 6, which is 2. So you should use 2 here. Yeah. Thanks for let me know. I mean, there's when you calculate that, you should able to see the problem. I mean, but I apologize. But the formula in the slide is correct. Just when I apply it, it's like a little bit wrong. So I just this not be 5. This should be x21. It should be 6. Okay. And this number is not there. Should be this should be 6 as well. Okay. I think the rest will be right. I mean, but just to I'm sorry for the for that part. Okay. Sorry for the typo. For some reason that escapes me. Oh, okay. 你睇嗰度問。我打開呢個就咪個問題太長，喺個鬧嚟。 So this is also the last U reply as well, because next one will be just review. So I'm not going to do any U reply. You will do the real U reply. I mean, to the CTE will be next Monday. Okay. Well, when you're happy, time flies. It's relativity, right? The Einstein said, right? When you're happy, the time flies. Actually, that's good for you, right? If that worth your every penny that you pay for the tuition. If you do nothing, then it's not learning. Then why you're here? You're learning by practice, right? Learning by doing. Just by sitting is not going to learn. I mean, human nature is like people want to be lazy. We want not to do anything, but that is a system that forces you to learn. That's we set a system to make sure that you can't control yourself. That's the problem. Our mind cannot control yourself. There's always the devils and the angel in your head fight each other, right? Always you need some help. I think we can slowly start. Any tips for the test? The tips would be just look at our assignment and our past paper. That would be the best estimate. Okay. What method? I think the method we already discussed everything in the class. I don't know MSc, MSR. Oh, I probably. So MSc, if you recall, actually this guy is simply the MSG and MSG, right? Some of with a cross group, right? MSG, right? I'll just go back to the ANOVA slide. This is simply an ANOVA thing. Look at this. See the MSG, C is 2, same thing. Yeah, C is only 2 because only 2 groups. Whether you have X or no X, and MSW is the MSE, that thing. Okay, the same thing. Same thing, right? The same thing here. But group only 2, right? But the group is a little bit tricky, but that is simply as what you say, right? The group is whether you're beta or no beta. Okay, group with beta and group with beta. Okay. Is that okay? I mean, just the width idea. Okay, and basically the simplest thing is okay to give the idea. Okay. So to recall what is ANOVA, okay, simply just 2 group ANOVA. What does that do? You have 1 group normal, the bell curve, group 1, right? and there's group 2 there, right? Sorry, not so bad, but anyway, forgive me. And this is mu1, this is mu2, right? And they have sigma the same, right? That's ANOVA set, right? The ANOVA is trying to do is mu1 equal to mu2, right? And the alternative is they are not, right? How do we do that? How do we do ANOVA? ANOVA, the F test is, the idea is, okay, let's consider the following. Look at the data, right? The data, or data 1 may be all here, right? I don't know where, but they may be somewhere here. And data 2 will be somewhere here, there, right? Right? And ANOVA idea is you, under they're the same group, normal, then you can calculate variance within each group, right? Right? You can calculate variance within each group, right? That guy is called MSW, or in regression is MSE, right? And then you can also calculate that the case that how the average of this, okay, compared to overall mean there, looking at how this related to the center, right? You can estimate variance by looking at how each value compared to the overall, right? And if the null is true, okay, the variance of this sample mean, right, which is x bar 1 and x bar 2, the variance of these two must be very small, or should be close to 0, right? If the actual difference between them, they will be very apart, right? So comparing to this variance is what we do, okay? So now let's go back to the question. The F test is comparing MSW over MSG, right? Okay, but now there's idea talking about, the question is, what is Z test, what is T test, what is F test? Okay, now first go to F test. F test is unrelated to these two. F test simply looking at variance. Compare one group X, follow a normal. I don't know what the mu is, mu X, sigma square X, okay? And another group Y is mu Y, sigma square Y, okay? I don't care if they are same mean or not. Two bell curve, okay? Different mean, potentially different variance. What I want to know is F test is asking whether this is equal to this or not. Just look at the variance. As long as there are two bell curves, I have two bell, I want to know if they're the same variance or not. Okay? Application is the stock analysis. You have two stock, they may perform differently. I want to see the variance, the risk is that equal or not. Right? The F test is very simple, right? Just F test is simply, if you recall, it's just S square of X over S square of Y, right? And this will have follow normal distribution. Say this NX, NY, how many of them, right? It will be NX minus 1, NY minus 1, right? That is F test, okay? It's unrelated. F test is just compare variance, okay? It's nothing about the mean. As long as you assume that bell, this thing holds, okay? Nothing about the mean. Just simply about two bell curve. I want to know if the variance are the same or not. That's it. Okay, that's it. That's nothing with the Z and T. Okay, I mean, there's some relationship, but I don't want to talk about that. But that's it. Okay. The next is about Z and T. What is Z test? Z test is actually, you shouldn't think too hard, right? Because Z test is something very simple. Is I have a X which follow normal distribution, right? Suppose, right? And under Z test means I have hypothesis, mu is equal to some number A, right? And this X will follow this, right? And if this is correct, it should be here, right? If this is right, if I collect the data, it should be around A. If it's too much different from A, then we are unhappy. Then we will say the alternative is correct, right? The alternative decide what we say away, right? The alternative is mu not equal to A, say 2 tail, right? So if it is here, right, or here, then we're done. For this to work, we need to know the sigma square. So if we know the sigma square, if we want to see whether the population mean is equal to some value, then z-test. If we know the population variance, okay, if we want to see the population mean is equal to some number or not, that's how we do the z-test. Okay. If we don't know sigma, t-test. Because what we learn is if this, I don't know that, but t under the null, x minus a over sigma, okay, will be t n minus 1, right? Maybe I used x bar is better, right? That's what we mean, right? Because this x bar will be sigma, right? So instead of this, I would use the s over root n. Okay. So that will be the way we do. There's a t-test, right? Okay. So t-test is testing whether the population mean equal to what value. If you know sigma, z-test. You don't know that, t-test, right? Well, you have to know what the t1 and the t, right? Because whether you know the population value, that's it. That's how you know. So the question is, no, z is always you can use whenever, right? T-test is also usually you would can do whatever. There's no restriction. As long as you assume that the underlying is normal, this will apply. And of course, there's something is called the z-test is proportion data. Proportion data. Then you require the MP and N must be bigger than 5. That one you need to good. Otherwise, it's a binomial. So that's it. There's a for normal approximation you need that. But that is it. I think that's the only thing we have to be careful about that. But for sample mean, you don't need anything about N. Okay, because we assume by construction is normal. Okay. Oh, chi-square test beyond the scope of a class, but F is simply, this is actually follow, the S actually for chi-square. Okay, so you ask this question. So this is beyond the scope of our class, okay? So the question is, what chi-square is if you want to test where sigma square is equal to a certain value, and S square is not equal to a certain value, then use chi-square test. That's one way to do it. Because that is follow the S square follow chi-square. Okay, and that's actually why you can have F test, because F is chi-square degree of N over degree of M, something like that. So that is the chi-square, that's the F test if you remember the formula. But chi-square is not in our syllabus, so but if you want to know, that's the one way. And chi-square is also useful to check whether you give me the data, is the data follow, say, Poisson, the data follow negative for hypergeometric, whether the data fit the distribution, is you use chi-square. I mean, there's some way to do something, but this I don't think you even learn it in the second class. Maybe in the third or fourth class of statistics you learn it. So it's too much beyond our scope. Okay, so let me stop here. Okay. I hope I answered the question you have. So that's different between the F test and chi-square test. I think I answered the question. Yeah, I can't believe that this is the last class. But we still have one more to see before we have the exam. So hopefully next class be there. The exam, I think we will, because we are in the down there. So the exact time I think will be at 10:45, right? So we give the 15 minutes buffer. But if everyone is there, then we start, okay? Okay, to don't want everyone waste, right? Waste of time. So everyone there, we start, but otherwise, we'll wait at 4 because it may take time for you to go up, maybe there rain or whatever, right? So I think 45 would be just 1 hour only. Open book means that you can bring whatever paper you want, no computer, paper open book. And yes, if I think it's complicated, I write in the question that you can write Excel formula, then you can write Excel formula, right? If you really don't know how to do it, then you can write Excel formula, we still give you partial credit for that. So don't worry about that. If you don't know everything, then just write Excel. We'll get you most of the credit, okay? How long? 1 hour? I do, right? I don't just teach one, but what I teach is another class besides this. I teach a master class, master statistics, and also the PhD level microeconomics theory, which is what my research do. I also teach next semester. I also teach the general education, NA college, yeah, New Year's College, yeah. So teach you how to be a university college freshman. Something the first time I taught, but if I see you next time, that would be very happy. Yeah, for the spring, you feel like winter, but add-in is well, what you learn, what I ask you, ANOVA and the regression is to how to read the output of add-in, right? Whether you know how to collect other issue, I expect you know how to do it, but I don't want you to know how to operate the add-in. It's not part of the part, but look at read the output. So I will do it. Draw conclusion, just tell me whether you reject X now or not. Okay. At the 5% significant level. Let's see. This is our last fun. Oh yeah, eventually everyone got it right. This is the day that everyone with consensus for the last time. Yeah, almost consensus on the rainy day. As is good. Oh, I'm surprised who say sunny. Maybe he is very happy. He also is happy the class is over. Which I agree is over. Almost over. I think everyone's okay. Okay. Just to remind you that please talk to TA, right? Because this is the last week for TA, right? After that, the TA will not, yeah, never give up. Fight if you want to. Yep. I hope you will not be too stressed for that because we only have 1 hour, right? And today is so cold. Yeah. Make sure that you have enough clothing when you go to exam theater, because I don't know how cold is that place because it's a medical school. I guess they would have a temperature much lower than what we think, right? Because they have lab coat, everyone there, right? So hopefully you would be keep yourself. So I don't know what's that.
对，获得一个今天放$5看会变出什么东西？什么？$5？$5只有这样？哎，他这个是为了那个寿星而做的哎。然后漂亮又浮夸的毛巾。哇！1、2、3、4、5。华夫饼有3位陪我吃。
So it shows you that you give more tips, then you get better service. Unfortunately for me, I cannot accept any tips. So no matter what you do, the service remains the same. So anyway, it's fun to watch, right? So hope those who feel a little depressed are a little bit more happier. So what left is only 2 things. So go again the F test again. Okay, it's just the main idea of this F-test behind is actually similar to what we see. Why this is F-test? The main idea is whether you look at the case where beta is 0, but that's not. So basically looking at the problem where you look at beta is 0, look at this, right? Actually, this measuring SSE, right? Without this, right? So you explain the model, the variance will measure SSE, right? But when you have the model, right, that you measure, that will be MSR, right? So that is actually comparing two variants. The same idea we see here, right? Just the thing that this, right, you compared it within and comparing across, right? So the same style here, okay? Because MSE is measuring here. This is MSE, right? And you calculate that is MSR. Okay. I mean, to be honest, I don't think you need to know this graph because you already know is in your mind F test is testing whether beta is 0 or not. And same as T, that's it. You don't need to go further, right? Because that's you need to know. I mean, of course, you when you go to a second class of statistics, you will learn it again. Okay. So that's why I don't want to spend too much time on that, right? But as far as we can go is like this. So here is trying to tell you that how you can calculate the MSR, MSE, right? Come from the SSI, SSE, right? And F is the ratio, and you compare the F test, right? Just to remind you how you calculate this number, this critical value is simply F dot inward 0.0, it's right tail test, so it's 0.95, 1 and 3, okay? Because you're doing F is like this, you're doing 5% here, right? So it's the inward is the right hand side one, okay? And of course you can do the p-value, right? If you want to do p-value the same, just this number will be this F dot this, right? 1.22, 1 and 3, true, okay? Do note that this is the area on the left hand side. 1 subtract, give the p-value. Is that okay? And this is the value that you will see in Excel output there, okay? So this really marks the very end of the Excel function, okay? Is that okay? If that's okay, then we go to the very next one, the very last thing, okay? Will be this, okay? This one is saying that if I now have a regression line, right? So the question is like this. I have X and Y, I made docs here, data, right? And what I left is I now have a line, and that is my, right? So this is my solution. And once I test hypothesis, beta is not 0, then this model is good. Now we can use the model, right? And this line is our best guess, right? That means that if you give me a particular 1x0 here, what would be my guess? Go up there. This will be A plus bx0, right? And this is our best guess, right? This is our best guess. This is how we use the model, right? This is the typhoon satellite image, the line. If you recall, just try to convince you this is what we have seen all the time, right? Let's look at the satellite image. Maybe forecast. We put Hong Kong. Right, so you already see this diagram here, right? Hopefully you can see, right? The dotted line are the best estimate, right? And of course, we want beside this, we want interval, which is the yellow one, right? Because we just don't want the mean, we also want how accurate it is, right? We already showed you how to tell us how accurate the A and the B's are, right? Or the right? A and B have interval, right? So we want to estimate this, we also want the interval, right? The interval estimate for that, we just coefficient. But now we want our predict X and Y, we want interval. In the other words, actually we will be doing is, you can easily draw is, there will be interval, something like this, a band, okay? It's called a band down, right? So if you learn technical analysis, this is called Bollinger Band, right? This +2 minus 2SD if you learn that, but otherwise that would be something along that line. Okay. So we can show the variance is this formula, right? So that means that you can add m plus minus t this guy, then we give you the interval estimate, right? So the formula is very simple, right? So we will just simply do this, right? Plus minus, right? Of that thing, then you're done, right? So we have seen that many times already, right? So this is the, you predict, and this is the thing that the t critical value, and this is the model we have, okay? And this is what we want, right? That's the end. Okay, what remain, of course, I show you the example, you can do the calculation as well, right? Because, but I don't see that, so you can do the calculation. If your X is 0 like this, what's a prediction? And you calculate the variance and you can do the interval, right? You can tell me that, okay, in the model, X is 6. What is my guess on Y with 8.1? But that's not sufficient. We want a range because it hardly 8.1. You can tell me that, okay, turn out to be 95% will be within that range. That is what we want, right? We don't want me to give me just one number. We want to give me one number, but also want the range. Then I can see what action can be taken, right? So that would be the last bullet point there. So basically that's over. What left is show you how to generate the Excel add-in and interpret the table that will be useful for exam, right? So far we just talked about how to do your assignment, right? But now we show you how to do the exam, okay? The exam will be, if we ask this chapter, we'll be asking you to run the add-in and see the output and try to explain, same as ANOVA, right? We are not asking you to run the calculation in the exam, right? That is waste of time, right? Rather, I give you Excel output, you can use it to answer some question, right? That is the goal. So let me do the Excel add-in. Before we do that, let me save the file so that so this is our last file, okay? Where we so this is the data. Now we want to do add-in. In case you forget how we do it, is file, options, okay? I don't know how to use Macintosh. I never own a Macintosh, so don't ask me, but that's doable in Macintosh anyway. Add in, and then go, option, file, so file, option, add in, and then NS2 pack. Let me repeat what I do, file, option, add in, go, NS2 pack. Once it's done, if you do it last time, it should be here, okay? Mac can do it. So here is the And probably you ask, what if I don't use Excel, I use other software? That's no problem. Output is very similar. For other software, you look at the R or Python, they give you very similar result. So I do data analytics, okay, and I go to regression, okay. That is actually very easy. I only need to tell the software what's Y, what's X. I tell the label because of a label, and that's over. Okay. I have label there. Y is this A1 to A6. X is also B1 to B6. Once I'm done, okay, label is there. Then I click OK, then it's over. But the output range I want to put in the same page because that would make it easier to read. B1 there, okay. Then once I'm done, I just input this, and this, right? I click OK. Yeah, it's there, right? So let us read one by one, okay? You can forget. I just highlight the things you can forget for the moment. This is the thing that you will learn in the future, okay? But this is the one we figure out already. This is the R square, right? If you really, it's RSQ. If you really don't believe me, believe your Excel function, okay? I just show the formula test here. And this is just the STD-EXY. YX or XY? Yeah, YX. Okay. So Y and X. Okay, so the same thing. So you know how to do that. Okay. And observation is 5. I think it's easy to see. 5, right? Now, you know that. Okay. And ANOVA, also we need to know how to do it. Okay. For ANOVA, already know it because for regression, it's always 1 because you only have one X, right? If you're more than 1X, you will be, if you're 2X, then you will be 2. But in the simple regression for our class, always 1. Always 1. And this is N minus C minus 1. Okay. So it must, okay, must be N minus 1. So this is N is here, N minus 1 here. And this is N minus 2. Okay, let me write that down. This must be in our model, this must N minus 1. So N minus 2. And this is N minus 1. This is always 1. Okay, it's always 1 for our case. Okay, when you go to second course, it will be 2, 3, 4, 5, 6 more. But for our class, always 1 because we only use one data. Okay, and this is SSR, right? This is SSE, this is SST, SST. This is SSR. This is SSE. In case you forget, SSR is summation y hat minus y bar square, right? What you guess minus what you want to explain, right? SST is just summation y minus y bar square. And SSE is how accurate you're doing, so it's just y minus y hat square, right? And same as ANOVA, you divide anything from the F by E, will give you G, right? 4.9 over 1 is 4.9. 13.1 divided by 3 gives you this guy, right? So you can check. And the F will be simply this divided by this, right? This divided by this gives you this guy, right? 4.9 divided by 4.3667 is that, right? Because this is MSR over MSE, right? Just to remind you, again, in case you forget, this is MSR, right? This is MSE, right? F is MSR over MS, right? And this F, the p-value, right? This p-value, I can just do that here. F is 1 minus, right? Because you want the right-hand side. F dot inward, because I have the value I inverted. This guy, right? Because right-hand side, right tail test, right? The degree of freedom is just actually 1 and 3. 1 and is 1 and 3 here. Okay. Sorry. Sorry, it's a distribution, right? Sorry. It's a distribution. It's the value, right? So the true. So this is how you get this number. Okay. So in this particular case here, we can see this p-value is greater than 5%. So you cannot say beta is 0. So basically the regression is useless. Okay. So I hope you know everything on NOV. Is there any question? Because I erase it and go to the next table. Any question, feel free to ask, because last chance, right? Oh, you need to know what does that mean by this table, right? How to get this value, right? You don't need to worry about how to get from the data, just a table, right? Suppose the question is, I take away this 3, you know how to fill in. I take away this number, you can fill that in the rest, right? If I forget about this, you can tell me this is the formula to calculate, right? That's exactly what I told you. Yes. N is number of observation. N is 5. How many pairs of X and Y we have, right? 5. Here, the data we have is 5 number of data, right? And it's here 1, 2, 3, 4, 5. Is that okay? Of course, you can, if you want the formula to count, that's it, right? But that is that okay for this table? This is what I'm asking, right? Usually, what I do is in the past, it's just I just put question mark on some of the table, right? Then you can tell me what the number they are and what kind of decision you want to make, right? That's it. Is there any question for this one? Good. Okay. Then because there's a question on the how to calculate is there already. Is this formula? I hope that's okay. This formula is F test, right? Because this is F statistics. You look at the value on the right hand side, the D F this to the left, so 1 minus to the right hand side, right? Now, if that's okay, but of course, if you still unsure, you can ask me next class as well, right? It's not the end of the world, right? But you also have the TA to help you, but try to get help from TA as early as possible because he also is very busy as well, right? So as you can see, the intercept is 3.9. We know how to get it already, right? How to get this one is also very simple, right? And these two are very complicated, if you recall, right? There's some way to calculate that, right? Right? This is a little bit complicated. This is easier, S over SXX, right? Right? And this is slightly more complicated, right? But these are all the formula of the, if you want the formula, right? This is SA, right? This is SB. You look at the textbook, right? And you divide anything from column E to column F gives you this number. And this divide by this gives you this guy. Right? Maybe I use the blue color there, right? This divide this, give you this. This divide that, give you this, right? The T stat, right? And you can look at the p-value. Come here. I just saw one of them because the two-tailed test. So it's just 1 minus 2 times 1 minus T this guy. Degree of freedom is N minus 2. So N is 5. 5 minus 2, 3, 2. You can do the same for the above, right? If you want to have fun, you should check how to get this one, right? Of course, you can check my slide, everything in my slide is there, but you don't want to look at the slide, but you can check it out, right? And these are the interval I mentioned already, right? You calculate T critical value, right? And plus minus this guy, right? You can calculate this as well. right? I just show one of them how to calculate this guy. You can do the rest since we have time. So the critical, so this one will be this guy, right? Plus the critical value. The critical value will be the T at U195. So the N is 2.5%. So 0.975. Okay. Degree of freedom is N minus 2. N is 5. 3. That's critical value. And you multiply by the standard error. Okay. So I hope that's pretty much end the way we do, right? So let the other one we subtract, right? So that would be 5. Okay. So everything you know we learn is all there, right? So basically this summarize this table. I hope at the end of this class, probably you forget everything. That is very normal. I don't blame you for that, but you should be able to look at this table, right? And you can tell me, okay, this p value is more than 5%, so you don't reject the null. So this model is essentially useless, but in general, you can tell me whether it's useful. This is the main thing you will do when you go into practice, right? You run the regression and check every coefficient, whether they're good or bad, and you apply it to the model. Okay, so I hope that marks the very end of our course. So just prepare for as I told you, in order to prepare for the upcoming test, try to do the past paper. We can discuss in the class. We go into the detail. To be compatible with regulation, next class will not be record. So because I discuss exam papers, but you can take your own video. I don't mind, but I can't post it on the web. Okay, so there's something, but you can top of whatever notes we want. Okay, no problem. You can take pictures. That's no problem. Okay, so good luck if you enjoy your celebration this week, because there's a Thanksgiving celebration, I think, in the US. But if you do the turkey thing, you will do it tomorrow, right? So enjoy. I will see you next Monday. Good luck for the rest of the semester, and see you in the future. So I stay around to answer any question you may do, because it's still 3 minutes earlier, so I stay around. 呢個係 SXX 嗰啲啊。哦，呢個有 formula 喺度咯。都代表緊啲咩啊？個 X 哦，你個 B 係咁咯。SXX S over X SXX 嚟㗎，咁我哋咁計過一次你 SXX 呢個嘢，呢個除翻嚟到，你隔我已經條數一樣嘅，領路範美覺得係一樣咯，我哋有。咁我哋幾時？我想問下 F test 係咪一樣係 one tail， 即係一定有？ANOVA 一定係 one tail，ANOVA 一定係。但係如果你係 compare 兩個 variable 就唔係 compare